is in the vertical. My initial position is going to be 122.5 meters. My final position is going to be 0 meters. And that's all I've been given in the vertical. So I'm going to use my kinematics to solve for the rest of this question. So the time it takes to hit the ground. I only have enough variables in my vertical direction, so I have to use those variables. I do not have enough variables in my horizontal. So I'm going to use this kinematic. And I've substituted in my vertical acceleration due to gravity and my vertical displacements, but it's really the same as on the equation sheet. My initial velocity is 0. My final position is 0. So when I rearrange my equation, I'm going to subtract my initial position on both sides. Then I'm going to multiply both sides by 2 to get rid of the 1/2. Then I'm going to divide both sides by g to get t by itself, and since t is squared, I'm going to square root it. So when I plug in my numbers, and I plug it into my calculator, I get 5 seconds. That is the flight time. I'm going to put that back in my chart. And that is how long it took to go vertically and horizontally, right? It's the same motion. The ball is moving forward and moving down at the same time. The range. So I'm going to use that same equation in the horizontal. But I can cross off this part because there's no acceleration, and cross off this part because there is no initial position. And that leaves me with this equation here. So my velocity is 8 times my time, which is 5, gives me a displacement in the horizontal of 40 meters. Part C asks for the final vertical velocity. So I'll use the first kinematic. If I have no initial, it just is my acceleration times time, giving me negative 50 meters per second. It's negative because it's moving in the downward direction. Let's see, so this is A, B, C. Part D asks the final vertical velocity in the horizontal direction. And it's going to be the same as my initial because there's no acceleration in the horizontal. I'm not going to solve another one, but I will show you for number 3. It gives you your x is 45 meters and your y is 50 meters, right? Your g. And it asks you to find this velocity, right? We were given to it in the previous problems. But you need to solve for your time first, right? We're going to solve for time in the y, and then you can use that to solve for your velocity in the x direction.